Today I'm going to talk about faster than light travel. Its history from not even theoretical to now only a few months ago being considered significantly closer to humanity's grasp than we ever thought possible. So in May of 1994, a physicist by the name of Miguel Alcubierre created a set of solutions to Einstein's equation of general relativity, which is how mass causes space-time and the world we live in to curve in different directions and create effects like gravity. Alcubierre realized that there was no solution with normal mass that could allow for faster than light travel. So he worked backwards. He found a manifold, a curvature of space that would allow for faster than light travel, and then worked backwards through Einstein's equations of general relativity to figure out what mass we needed to be able to generate those shapes. Now, early on, the Alcubierre drives were considered wildly speculative, mainly because the energy required to generate one was more than exists in the observable universe, so much so that even he began to dismiss the idea that it was possible. However, many physicists who grew up on Star Wars and Star Trek like I did started working on Alcubierre's equations. In fact, we ended up getting the mass requirements down to significantly less than what Alcubierre originally proposed. So much less that it was considered possible. Not necessarily practical, but definitely possible. The other big caveat to Alcubierre's equations were that they required a piece of material that had negative mass or negative energy density, as it's often referred to in these contexts. And while some physicists were able to figure out workarounds for that, they ended up not being able to do what Alcubierre's equations could do, which was allow for faster than light travel, or warp speed. And we've kind of been stuck on this idea that we will never be able to achieve warp speed without the discovery of some other type of matter that has negative energy density. That was until a few months ago in 2021, when a physicist working at a DARPA laboratory in the UK, he was working on this thing called a Casimir cavity, which is just like a really, really small capacitor. And he had also been a fan of Alcubierre's work for a very long time, and it helped actually optimize his equations. Upon looking at this one specific Casimir cavity on a random day during the project, he discovered that it was predicting that negative energy density that him and many other physicists had been seeking for so long. And it was at this point where the idea of a working warp drive went from this science fiction, possibility to we might actually be able to do this in the next couple of centuries, if not decades. And it's through just sheer luck that we have gone from one of the most fantastical and outrageous concepts of sci-fi to being something concrete and realistic that we may actually be able to see in our lifetime. So thank you.